Hello everyone. Let's provide the solution to this problem. We have k to the power of 3 plus k equals 30. And from here, what do? K to the power of 3 plus k equals 30. Let us express 30 in this form. I think it's possible. So we have k to the power of 3 plus k equals 27 plus 3. This is because I can express 27 in this form, and 27 out of 30 will have 3 more. So this is okay. So now k to the power of 3 plus k is equal to 3 to the power of 3 plus 3. Now we rearrange what we have. So we're going to have k to the power of 3 minus 3 to the power of 3. So we'll have this separately, then plus k. This k will come down here, then this becomes minus 3, and then everything is equal to 0. Now we have this to deal with, but then we are going to break this down, knowing that a to the power of 3 minus b to the power of 3 is equal to a minus b into a squared plus ab plus b squared. Then we close this up. Okay, so to continue, then in place of k to the power of 3 minus b minus 3 to the power of 3, I'll be having k minus 3. K minus 3, we'll have this. Then open bracket, a squared becomes k squared. Then plus ab, that will be k times 3, that is 3k. Then plus b squared, that will be 3 squared, and it is 9. Close this. Then plus open bracket k minus 3, and this is equal to 0. Now from here we have this and we have that. They are the same thing, so we can factorize. K minus 3 is a common factor. Then here I have k squared plus 3k plus 9. Then plus k minus 3 divided by k minus 3 will give 1. So I'll close this and equate to 0. Now we open the inner bracket here, so we have k minus 3, the common factor. Then if I open the inner bracket, I have k squared plus 3k plus 10 equals 0, because 9 plus 1 is 10. To continue with this, we have k minus 3 to be equal to 0, or k squared plus 3k plus 10 is equal to 0. Okay, so what I'm doing here is this. I am applying zero product rule. If you have two numbers to multiply in order to get 0, it means that either of them or both of them must be equal to 0. So that's what I'm applying. Either this is 0 or this is equal to 0. So now k is equal to 0 plus 3, or what we have over there. But then we'll go back there to deal with this quadratic equation. So our k is equal to 3, and this is the real solution to the problem. K equals 3. Now let's deal with the other value. No, let's deal with this equation. To this equation, we will use the formula. Our k is equal to minus b plus or minus square root of b squared. B squared minus 4ac. Everything is over 2 times a, that is 2a. But now our a is our a is 1, that is the coefficient of k squared. Our b is 3, the coefficient of k, and then our c is 10, that is the constant. Let's substitute into this formula. K will now be minus 3 because b is 3 plus or minus b squared, that will be 3 squared, minus 4 times a times c, because a is 1 and c is 10. Divide this by 2 times 1, which is 2. Now k is equal to minus 3 plus or minus, then we have 3 squared is 9, minus 4 times 1 times 10, that is 40. So write 40 over there, and we divide this by 2. Okay, so the next thing we will do is to subtract what we have there. Now sometimes you'll be tempted to find the square root of 9 and then find the square root of 10, but that would be wrong. You have to evaluate what you have under the square root before you take the square root of both sides. Take the square root of the number you have. K now will be minus 3 plus or minus square root. Okay, 9 minus this is 31, so we have square root of negative 31. Then this is over 2. But now this 31 here is going to give us a complex solution because of the negative. So we can write k to be equal to minus 3 plus or minus square root of 31. I'm picking out the negative from there. Multiply by square root of negative 1. So that if I multiply these two, I will still have square root of negative 31. Then I will divide this by 2. Now we continue so that k is equal to minus 3 plus or minus square root of 31 times I, because that I is imaginary. Square root of negative 1 is imaginary and is I. So we divide this by 2. Now let's continue from here. Okay, so let's continue from here. So this means that k is equal to minus 3 plus or minus, we write I before root 31. Then we divide this by 2. Remember, this is a 2-in-1 solution, right? So let's bring the 3 solutions together. The first one is k1 and is equal to 3, the real solution. Then the second one is k2, it is obtained from here. We have minus 3 plus I root 31. Then we divide this by 2. Then the next one is k3, which is minus 3 minus I root 31. Then we divide by 2. So these are the 3 solutions to the equation. But mind you, only this is the real solution. This and this are complex solutions.